Okay, so again, this is still for the homework for 6.4. And we talked about power of 0. And now we're going to talk about the rules for dividing with the same basis, I should say. Okay. So just to review, when we multiply same bases, what do we do with those exponents? Right, we add the exponents. Okay. All right, so division is like the opposite of multiplication. And so what do you think we do if we are dividing with the same base? What do we do with those exponents? The opposite of addition. We're going to subtract. So here we can run into some issues. But we'll see what happens. Okay. So again, by base, I mean the same like variable. And if we have something like this, we have x to the 5th over x squared. So we have the same base, right? They're both x's. And if we wrote this out, okay, we're going to see what happens. So first off, I want to ask if you agree that anything over itself, or a number divided by itself equals 1. Hopefully you agree with me, right? So if x equals, let's say here, 4. Okay? So if I have 4 over 4, what does that equal? Right, it equals 1. And if I have 1 times anything, does it change it? No. So meaning that here I have x over x. So if this were a number, it'd be the same number, both top and bottom, because it's the same letter. So x over x is the same thing as 1. This x over the x is also the same thing as 1, right? And 1 times what's left over doesn't change anything. So these 2 on top cancel out with these 2 on the bottom. So what's left? X to the 3rd. And we get that from doing 5 minus 2, right? That's the shortcut. We can do that with numbers as well, if numbers were the base. So if we had 9 to the power of 7 over 9 to the power of 3. Again, if we have the same base, we keep the same base. We don't consider it 9 divided by 9. Because what we're doing is we're reducing the variables, okay? So why I wrote out or chose 7, I don't know, but let's do it. 1, 2, 3. Okay, so again, 9 to the power of 7 would mean we would have 9 times itself 7 times. 9 to the power of 3 means we would have 9 times itself 3 times. 9 divided by 9 is 1. This is 1. And this is 1. What's left? 9 to the power of 4, right? So 7 minus 3 would have gotten us 2. Now, where I said we might run into problems is that sometimes this is flipped over, where we have more whatever x is, or whatever the case may be, on the bottom. So you always want to leave your answer with positive exponents. Okay? I don't think anybody in this class said that their favorite movie or one of their movies that they liked was Monty Python, Life of Brian. But if you ever see that at the end, there's a catchy little tune about always looking on the bright side of life, right? We want to think positive. So in order to have our positive exponents, we have to leave them where the most of them are. And what I mean by that is, in this case, if I took this example and flipped it, okay, so I know from before that this x is going to cancel out with this x. X divided by x equals 1. This x divided by this x also equals 1. And where my x is at? They're all, all right. 1 second. All right, sorry about that. A guy came to give me this for roof repair from our hail damage that we had. Scared the crap out of me. Okay, so we were right here, and we saw that these x's, 2 x's on top, canceled out with 2 on the bottom. We have more x's on the bottom, so therefore they have to stay on the bottom. This answer is going to be a fraction. We have 3 x's left, so it's going to be x to the 3rd. And you always have to have something up here, right? So here, we saw that when this canceled out, we got 1, right? So 1 times 1 equals 1. So if there aren't any numbers there, any coefficients or anything like that, big numbers, then you have to have something there, and then I'll be 1. All right, let's do another one. I think the homework, they had some with numbers as their base, and they had like crazy ass exponents. So it was something like this. Okay, I don't want to write this out 23 times. So shortcut is if we do 7 minus 23. You get negative 16, okay? So if I wrote this as a base of 5 without a fraction, 7 minus 23 would be 5 to the negative 16th power, okay? But that's not how we have to answer it, because you always have to answer it with a positive exponent. So where are most of my 5s at? I have 23 5s on the bottom and only 7 on top. So I have more 5s in the bottom. So my answer for my 5 is going to stay in the bottom. So if you move something from top to bottom, you change the sign. You got to move it to make it positive. And again, had I, done 23 5s and 7 5s, as these 5s would cancel out, you're going to be left with 1 on top. Okay. So those exponent rules get a little tricky sometimes. But again, if you just kind of think about it and work through it with maybe a smaller example, then usually it'll help. So if we had something like this, let's say we had something like let's do that. So here we have x's, it's both top and bottom, which is cool. We can handle that. And we have a big 20 divided by 5. So 20 is the big number, and that's on top. So 20 divided by 5 is 4. We have more x's on top than we do on the bottom, right? So our x's will also be left on top. So 3 of these x's will cancel out with 3 of those, and we'll be left with x to the fourth. 7 minus 3 equals 4. If we had something like this, okay, 20 divided by 5 is still 4, big whole 4. But now we see that we have our x's, more x's on bottom than we do on top. So this is where our two guys are going to get divorced, okay? This 4 is big enough to stay up on top, but now our x's want to live in the bottom. That's where they're happy, that's where they want to stay. So if we do if we do 3 minus 7, we get 4. We leave the x's where they are, most of them are, and so they are happy down there, okay? And then let's do this one. Yep. In this case, we have more x's on top than we do on bottom. But here, when we look at our big numbers, right? 5 over 20. So we have a fraction. And just like in any other fraction, if the smaller number is on top than it is on the bottom, this is a proper fraction. So we're still going to have small number on top, big number on bottom, okay? So 5 over 20. I can divide 5 by 5 and get 1. 20 divided by 5, I get 4, okay? So instead of having 20 divided by 5 getting us a big 4, if it's flipped around, we still have a fraction. But when I look at my x's, I say, well, I have 7 x's on top, 3 on the bottom. So I still have more x's on top. Again, these guys are getting divorced. One's going up, one's going down. Okay, so 7 minus 3 gets us that 4. Usually you won't see it with that 1 in front. You'll usually see something that looks like that. Okay. And then last but not least, let's do this. So here, again, 5 over 20 will be 1 over 4. And then now I have more x's on the bottom. I have 7 of them still. And when I take 3 of those away, then I have x to the 4th, but again, more on the bottom. So I didn't have anything left over on top. No, there's not an x or a big 4. So I have to have that 1 in this case. Okay. So I'm always having to have something left on top if it turns into a fraction. Okay. And just to kill you with one more type of example. So you can have more than one variable. Okay. So let's look at this. We have A, B's, and C's. A's go with A's, B's go with B's, C's go with C's. Okay? And you take it each individually as they are. So here, when we look at the A's, I have 8 A's on top and 6 A's on bottom. I have more A's on top than I do on bottom. So when I subtract, I'm going to get a positive 2. So my A's are going to stay up on top. 8 minus 6 is 2. When I look at my B's, I have 3 B's on top, 9 on the bottom. I have more B's on the bottom this time. So now I'm going to have, when I subtract, I'm going to have the B's stay on the bottom. And so 3 minus 9 will get 6. Okay, so if there's more in the bottom, it stays in the bottom and stays positive. Here, I see that I have C and then C to the 5th on the bottom. Don't forget that there's that little 1 right there. So I have 1 C on top and 5 on the bottom. So when I take the difference, I'm going to have 4 C's left on the bottom. Okay. So sometimes your little guys will stay together and sometimes they split apart. Just what happens in life, right?